Welcome to Algebra 1. The learning goal for this episode is to learn how to solve and graph inequalities in one variable. First, some necessary vocabulary. We previously worked with equations where both sides equaled each other. We are now going to work with inequalities, where one side is going to be greater than, less than, greater than or equal to, or less than or equal to the other side. So, for example, x plus 5 greater than 2 refers to all values of x that, when you add 5 to them, will be greater than 2. This has an infinite number of solutions. If we have x equals 5 greater than or equal to 2, it refers to all values of x that when you add 5 to them are greater than or equal to 2. This has all the same solutions as the previous problem, plus one more, the value that actually makes it equal to 2. When we graph inequalities in one variable, we graph them on a number line and shade in all the points that satisfy the inequality. We then pay particular attention to the border point that divides the number line into solutions and non-solutions. If our inequality has a greater than or less than symbol in it, then that border point will be an open circle, indicating that the point itself is not a solution. So, for example, for x greater than 3, we shade in everything on the number line that is greater than 3, and we put an open circle on 3 itself because it is not a solution to our inequality. But if our inequality has a greater than or equal or less than or equal symbol in it, then the border point will be a closed or filled in circle, indicating that it is a solution. So, for example, x greater than or equal to 3 looks just like our previous solution, except there is now a closed circle on 3 itself. That indicates that there is one more solution, in this case 3, that satisfies the inequality. We can solve inequalities just like we solved equations by doing the same thing to both sides of the inequality, but with one exception. If we multiply or divide both sides of an inequality by a negative, then we have to flip the inequality sign. You can see this by thinking about the numbers 2 and 3. Clearly, 2 is less than 3, but if we multiply both sides by negative 1, negative 2 is now greater than negative 3, so we need to flip the inequality to a greater than symbol. Let's look at some examples. We want to solve and graph x minus 3 greater than 2. First, we solve this inequality just like we did equations. In this case, we add 3 to both sides. Then we graph x greater than 5, which is going to be an open circle on 5, indicating it is not a solution, but then shade everything greater than 5 to indicate that those points are solutions. It's always a good idea to spot check a few points on your graph, both solutions and non-solutions, in the original inequality. It's important to use the original one just in case you made any mistakes solving it. In this case, I might check 6 to see if it works. In the original, that would be 6 minus 3 is greater than 2, which simplifies down to 3 greater than 2, which is indeed true, so that point should be shaded, and it is. What about 7? Yep, that works too. 8.2? 4? No, 4 does not work in the original, and it's not shaded, so that's good. Spot checking a few points makes it more likely that we'll catch any mistakes we might have made. Let's try another example. Solve and graph 5 is greater than or equal to x plus 2. Again, we solve just like with equations. In this case, we'll subtract 2 from both sides. But notice that the x is on the right side of the equation. That's fine, but it sometimes confuses students with the inequality in figuring out which way to shade. If it does confuse you, then take a moment to rewrite it with x on the left side of the inequality. When you do that, notice you have to flip the inequality since we changed sides. Now we can graph it. Close circle on 3 since it's less than or equal to, then shade to the left. We should spot check a few points. 3 works. How about 2? Yes, it does. Negative 4? Yes. Positive 4? No. Keep in mind there are an infinite number of points that satisfy this inequality. Spot checking is just checking a few of them. Let's try one more. Negative 4x is greater than or equal to 8. We divide by negative 4 on both sides. But recall that if you multiply or divide by a negative, you have to flip the inequality. So notice that our solution is now x is less than or equal to negative 2. When we graph that, it will be a closed circle on negative 2, then shade to the left. If we spot check, negative 2 works in our original inequality. So does negative 3. So does 8. But 2 does not. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, the first question is, what are we trying to do here? What we're trying to do is solve and graph this inequality on a number line. How do we do that? First, we solve it just like we solve an equation. Now what? Now we graph it. In this case, a closed circle on 3 indicating that it is a solution, and then shade to the left. So what do we do next? We don't have to, but it's a good idea to spot check a few points. 3 works. 2 works. 5 does not. -2 does. Let's try another example. What are we trying to do here? Again, we're trying to solve and graph an inequality in one variable. What do we do first? First, we solve our inequality. This one is tricky for 2 reasons. First, we divide by -3, so we have to flip our inequality. But since our x is on the right side, and that's sometimes difficult to figure out for some students, we may want to rewrite the inequality with x on the left side, which requires us flipping the inequality again. What's the next step? No matter whether you decide to rewrite it with x on the left side or not, the graph is still the same. A closed circle on 5, then shaded to the left. What's next? We can spot check a few answers if we wish. Now we're finished. What does this problem ask us to do? Again, it asks us to solve and graph an inequality. What do we do first? We solve the inequality. This one is a 2-step inequality, so it takes a little bit longer, but the process is the same. Notice we did not have to flip the inequality because we did not multiply or divide by a negative, nor do we need to move x to the left side of the equation. Now what? Now we graph it. Open circle on -5, then shaded to the left since it's less than. What should we do next? It's always a good idea to spot check a few points from our graph in the original inequality. In this case, I tried -5, which does not work. -6 does. 0 does not. -10 does. It looks like our graph is probably correct. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video and work out the problem now, then press play to check. Here's the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve and graph inequalities in one variable. We did that by solving inequalities just like we did equations, except that when we multiply or divide by a negative, we have to flip the inequality. We also learned that if it was just greater than or less than, we used an open circle for the border point. But if it was greater than or equal to, or less than or equal to, we needed to fill in that border point to indicate it was indeed a solution.